Hello students, good afternoon. Today we will solve some problems on bode plot. First question is, draw the bode plot for given transfer function where gs is given by 16 multiplied by 1 plus 0.5 s divided by s square 1 plus 0.125 s multiplied by 1 plus 0.1 s. And from the graph determine phase crossover frequency, gain crossover frequency, phase margin, gain margin and stability of system. First, you have to draw bode plot. Substitute S is equal to J omega. Then for drawing magnitude plot, decide the corner frequency. For this term, for this 0, corner frequency is 2 radians per second. For this term, corner frequency is 8 radians per second, and for this term, corner frequency is 10 radians per second. And since there are two poles at origin and value of k is 16, so mark a point omega is equal to 4 radian per second, and from this point, from 4 radian per second, draw a line of minus 40 dB per decade. Why? Because there are two poles at the origin. So draw a line from 4 radians per second of minus 40 dB decade and produce this line. So this line meets on the y-axis at certain point, and this will be the starting point of bode plot. Value of k is 16. It means that omega is under root 16, which is 4, and here this is 1, 2, 3, 4, and from 4 we draw a line of minus 40 dB per decade, and this line cuts the y-axis at this point, and this is the starting point of bode plot. Next, corner frequency. First corner frequency is 2 radians, and this is for this 0. First corner frequency is 2 radians per second, and at this corner frequency, this 0 activated. This 0 is activated. So for 0, we know that there is plus 20 dB decade slope for 0. So this minus 40 dB decade line, the slope of this line changes from minus 40 to minus 20, because at this 2 dB, at this 2 radians per second frequency, slope of line changes from minus 40 to minus 20, because at this corner frequency 10 is activated. Then next corner frequency is 8 radians per second here, and at this corner frequency a pole is added. It means that minus 20 dB slope is increased by another minus 20 dB decade. So this minus 20 dB decade is changed to minus 40 dB decade. and at third corner frequency, which is 10, next pole is activated. So from 10 radians per second corner frequency, at 10 radians per corner frequency, slope is increases by minus 20 dB, which is minus 60 dB per decade. So first we determine the starting point of bode plot, and starting point of bode plot is decided by this. K is value of K is given by 16, and there is two poles at origin. So omega is 4 radians per second, and from 4 radians per second we draw a line of minus 40 dB per decade, and first corner frequency is 2 radians per second. So at 2 radians per second, 10 is activated. So this slope of this line changes from minus 40 to minus 20 dB decade, and in second corner frequency, which is 8 radians per second, one pole is added. So this minus 20 dB decade slope of this line changes by minus 40 dB per decade, and when at the third from the third corner frequency, second pole is activated. So at third corner frequency, slope is changes from minus 40 to minus 20 dB per decade, and phase plot is drawn by this observation by this table. When value of omega is 1, and this angle is same for all values of omega minus 180 degree, value of this phase angle is 0.716, point minus 0.57, and similarly this is plus 2.6, this is for 0, and resultant is this. So draw a plot between omega and resultant, and you get a phase plot like this. Then this magnitude plot crosses the 0 dB at this point. So this is the gain crossover frequency, and this phase plot crosses minus 180 degree at this point, and this is phase crossover frequency. And phase margin is given by this negative phase margin is given by minus 8, and this is the positive phase margin minus 2 dB, and there is negative phase gain margin, negative phase margin. It means that the system is unstable. Positive phase margin, positive gain margin means system is stable, and negative phase margin and negative gain margin means system is unstable. So this system is unstable. Next, draw the bode plot for GS. From the plot, find gain margin and phase margin. Value of K is given by 23.7, and there is one pole at origin. So starting point is omega is equal to 23.7, and from this point on omega on x-axis, when omega is equal to 23.7, draw a line of minus 20 dB per decade line, and produce this line so it curves on omega y axis. This is the line, and here you see that omega is 1, 10, if this is 10, 20, and 30, okay. And here it is that this is 23.7, and from this point we draw a line of minus 20 dB per decade and produce this line so that it cuts the y-axis at this point, at this point, because there is one pole at origin. Yeah. Then next next corner frequency is this. Next corner frequency is next corner frequency is 0.33 for this term. It means that from this corner frequency one pole is activated, so slope is changes from minus 20 dB to minus 40 dB. From this corner frequency, slope is changes from minus 20 to minus 40 dB. Next corner frequency is 1. Next corner frequency is 1. So 1 0 is added at this frequency. So slope of line is from minus 20 dB to minus 40 dB to minus 20 dB, because 1 0 is added at this corner frequency. This 0 is added at this corner frequency. So slope is changes from minus 40 to minus 20. Next corner frequency is 2, and at this corner frequency one pole is added, so slope changes from minus 20 to minus 40, and then this 0 is added at corner frequency 5, so slope changes from minus 40 to minus 20, and in this case one corner at corner frequency 10 radians per second, one pole is added, so at this corner frequency slope is changes to 9 minus 40 dB. Means first we draw a line of minus 20 dB per decade at 23.7 radians per second. Yes, this is the point where the value of omega is 23.7, and from this point we draw a line of minus 20 dB per decade, and this line cuts the y-axis at this point. Then first corner frequency is 0.33, and at this frequency one pole is added or activated, so this slope changes from minus 20 to minus 40, because when for pole minus 20 dB per decade is for the one pole. So and next corner frequency is 1, and in this frequency 1 0 is added, so this slope minus 40 dB per decade is changed into minus 20 dB per decade, because when 0 is added slope is change in slope is plus 20 dB per decade. And next corner frequency is 2, and in this corner from this corner frequency second pole is activated, so this slope is changes from minus 20 to minus 40, and next corner frequency is 5, and at this from this corner frequency 1 0 is added, so this slope changes minus what slope of this line changes from minus 40 to minus 20, and in the last corner frequency is 10 radians per second, and at this corner frequency one pole is added, so slope is changes from minus 20 to minus 40, and this is the final magnitude bode law. And phase plot is given by this table. When value of omega is zero point 0.1, this is the angle for pole at origin. For this pole, angle given for the next pole angle is given. For next pole, angle is given 0, and for angle is given for 0, and resultant phase angle of given transfer function is this at omega is 0.1. Similarly, so you draw a graph between omega and resultant angle. You get a graph like this, and here this is the gain crossover frequency, and there is no phase crossover frequency because this phase plot is not touching the the axis of minus 180 degree. So gain margin is infinite, and phase margin is plus 34 degrees. So positive phase margin, positive gain margin means system is stable. This is the bode plot where GS is given by this. First you write the GS in time constant form in this form, and then calculate. This is the first corner frequency. For second corner frequency, for calculating second corner frequency, compare this equation with the standard equation, and comparing this equation with the standard equation, we get a value of omega n is 16 radian. This is the second corner frequency. First corner frequency is 3 radians per second. Second corner frequency is 16 radians per second. There is one pole at origin, and value of K is 6. So so on omega axis, mark the point at 6, and from this point draw a line of slope of minus 20 dB per decade, and this line meets the y-axis at certain point, and that point is the starting point. Then at omega is 3 radians per second corresponding to a 0, this point. At this point, the slope is increased by 20 dB per decade because 1 0 is added or 1 0 is activated. So slope is increased by plus 20 dB. So minus 20 dB plus 20 dB is 0 dB up to the next corner frequency 16 radians per second. And at 16 radians per second, a pair of complex poles is activated. So minus 40 dB per decade is slope is increased by slope is decreased by minus 40 dB per decade. Here, this is the point 1, 2, 3, 4, 5, 6. So from 6 radians per second, draw a line of minus 20 dB per decade, and this line cuts y-axis at this point. This is the starting point of bode plot, and At the first corner frequency, there is a addition of 0. So we get a 0 dB per decade line, and at the second corner frequency, pair of complex poles are added, so we get minus 40 dB per decade line. And from this table, you can draw a graph between omega and resultant angle this. You get a graph like this. This is the bode magnitude plot and bode phase plot. This is the magnitude plot of open loop transfer function Gs of certain system shown in figure. Determine open loop transfer function Gs if it is known that system is of minimum phase type and estimate the phase at each of the corner frequencies. Since system is of minimum phase type, then it has no poles and no zeros in the right half side of the S phase. Then you have to determine the value of Gs. Since initially we get a line parallel to the x-axis, it means that there is no zeros or no poles at origin. If we get a line parallel to x-axis, it means that there is no zeros or no poles at the origin. So in this case, there is no zeros or poles at origin. And value of omega is 1. So this 100 dB is the value of 20 log k. So we can say that 20 log k is equal to 100, and here we find out the value of k is equal to 10 raised to power 5. So Gs is equal to 10 raised to the power 5. First corner frequency is 5, and at this corner frequency there is a change of slope from 0 to minus 20 dB. 0 to minus 20 dB, it means that one pole is added at this frequency. So our term is 1 plus S divided by 5. S by 5, 5 is corner frequency. So 1 plus S by 5, and this term is in the denominator because there is an addition of 4. Then second corner frequency is 40 radians per second, and change in slope is from minus 20 to minus 40, minus 60. It means that there is a change of slope. Is minus 40 dB per decade. Means two poles are added at this corner frequency. So we can say that a term arises 1 plus S by 40 square of the whole term, because there are two poles at this corner frequency, and these are the poles. So this term appears in the denominator. Then at third corner frequency, change of slope is minus 20 dB per decade. So one pole is added at this corner frequency, and for addition of addition of 4 at this corner frequency, a term arises 1 plus s by 100, and this term will be in denominator into 4. So GS is equal to 10 raised to power 5 divided by 1 plus 0.2 s multiplied by 1 plus whole square of 1 plus 0.025 s multiplied by 1 plus 0.01 s, and then we calculate the phase at each corner frequency when omega is 5. Substitute the value of 5, 10 inverse imaginary part divided by real part, and value of s is 5. Value of omega is 5. Similarly for this case, and this term is for this. And if we substitute the value of omega, we get the phase angle is minus, we get the value of phase angle psi phi is minus 62.11 degrees. Similarly, you can calculate the value of phase angle when value of omega is 40, when value of omega is 100. Next question is, find the transfer function of given bode plot. This is the bode plot and you have to calculate the transfer function. There is a slope of plus 20 dB. Plus 20 dB means there is one pole or 0. Plus 20 dB, there is a slope of plus 20 dB, and for plus 20 dB means it means that there is one 0 at origin, and for zeros this S term appears in the numerator. And when value of omega is 1, the intercept on y-axis is 6. It means that 20 log k is equal to 6, and if we calculate the value of k is approximately 2.0, here. Then this is 2 multiplied by s, not 20. Then 2s, and next corner frequency is 1, and at this we get a 0 slope, means there is an addition of 1 pole at this point, so s plus 1, and next corner frequency is 10, and at this pole, from this corner frequency we get a line of slope minus 20 dB, means addition of second pole. So here in denominator, next term is added 1 plus s by 10. So we get value of GS is 20s divided by s plus 1 multiplied by s plus 10, which is the required transfer function. Time is over. Thank you.